All right, good morning, everybody, and welcome to Potter Electric's webinar on our addressable series system hardware. Before we get started, I do want to let everybody know that your microphones are muted and your cameras are turned off. If you have any questions, please enter them in the chat box, and I will take several breaks through the presentation to answer those questions if there are any. So first, I'd like to introduce myself. My name is James Brennan. I've been in the fire alarm industry almost 20 years now. I've been working for Potter since 2022. I've done just about every aspect on the integration side of this industry, including technician, project manager, national account commissioning, etc. So the first thing I'd like to talk about is our control panels. Potter has two series of control panels. The first is the IPA series of control panels, and that is Potter's proprietary line of panels. You have to be an ESD in order to buy those panels. You have to buy them directly through Potter. They are not available through distribution. There's three models of IPA panel: the IPA 60, the IPA 100, and the IPA 4000. The IPA 60 and IPA 100 are on what we would refer to as the small format PCB. This will make more sense in a little bit, but the big bullet points there are those two panels have a 5 amp power supply, 2 NACs, and 2 IOs. The IPA 4000 has a 10 amp power supply with 6 NACs and 4 IOs. The SLC capacity is the other notable difference between those panels. The IPA 60 is capable of handling 60 SLC devices, while the IPA 100 can do a full SLC loop of 127 devices. IPA 4000 can do 127 devices out of the box, but using SLC expansion cards, it is expandable up to 4,064 total SLC devices. A couple of much bigger bullet points about the IPA panels. They are all listed for clean agent releasing, and they are UUKL listed for smoke control. Now, on the other side of the aisle, we have the AFC series of panels. Those are our non-proprietary panels. They're available at electrical distribution and alarm distribution houses nationally and internationally. AFC 50 and the AFC 100 are going to be on that small format, 5 amp, 2 NAC, 2 IO. The ARC 100 is effectively the same panel as the AFC 100, with the exception of it is listed for clean agent releasing, where the AFC panels as a whole are only going to be water-based releasing. AFC 1000 is going to be a large format panel. Again, 127 SLC devices out of the box, expandable up to 1,270 using SLC expansion cards. AFC 50 is going to be limited to 50. AFC 100, ARC 100 are going to be limited to 100 total SLC devices. So let's take a look at the PCBs real quick. Here's the large format panel. That's what that panel is going to look like. First thing is that panel has a 4x40 LCD display. In the top right-hand corner, we've got our PCOM network connection. That's just an Ethernet port. Below that, on the right-hand side, we have 4 I/O circuits, input-output circuits. So we can program those to either work as a dry contact input or an output. If they're being used as an output, they will have a 1 amp circuit rating. Down in the bottom left-hand corner, we have our dedicated alarm, trouble, and supervisory relays. Those are not programmable. They're just going to follow the system status. Next to that is our battery charging terminals. Moving to the right is our 6 NACs. Those all have a 3 amp circuit rating. Moving to the right, we've got our 2 P-Link circuits. We'll talk more about P-Link here in just a little bit. And then last, and certainly not least, is our SLC terminals for that built-in SLC loop. All right, small format panels. Down in the bottom left-hand corner, you will notice that we have our battery charging terminals. I apologize. Moving to the right, we have our dedicated alarm, trouble, and supervisory relays. Sorry, give me just a second. I'm having some technical difficulties here. I apologize. All right, let's try that again. Battery charging terminals, alarm, trouble, and supervisory system status relays. The small panels have 2 I/O circuits as opposed to the 4 that you would see on the large panels. 2 NAC circuits, only 1 P-Link circuit on the small panels. SLC terminals. The small panels now come with a 4x20 display. It used to be a 2x16, but we've recently upgraded that to a 4x20. And then up in the top right-hand corner is that PCOM Ethernet port. Let's go ahead and talk about panel installation. All of our cabinets are made of 16-gauge sheet metal. The large format panels, you don't need to buy a separate kit if you're going to do a flush mount. The dead front is slightly larger than the main enclosure, so you can surface or flush mount them. And of course, UL says that we need to keep the temperature between 32 and 120 degrees, need to keep the humidity below 85%, need to verify that the panel is properly grounded. That's pretty common practice for life safety equipment. All of our cabinets have a keyhole for easy mounting, and of course they have knockouts that have been stamped into the enclosure. You can see there's the keyhole up top. The concept here would be that you can put 1 screw in the wall, throw your level on that enclosure, get it leveled, mark the other 4 holes, so one person could mount these enclosures. On the AC main side, our panels will operate on 120 or 240 volts. It is field selectable, and those terminals will take up to a 12-gauge wire. Closer look at those electrical terminals. You'll see that there's the jumper for the 120, 240 volt selection. Out of the factory, they come set from 120. And then we've got the hot terminal labeled B for black. We have the neutral terminal labeled W for white. And then finally, we have the ground terminal labeled green, labeled G for green. Our battery connections, that charging voltage is going to be right at 27.3 volts. Of course, our panels are only listed for use with sealed lead acid batteries. Our enclosure will house 8 or 18 amp hour batteries. It's not deep enough for 12s. And that charging circuit can handle a total of 55 amp hours of batteries total. You can see there that we would series those 12 volt batteries since fire alarms are 24 volt systems. Take a quick second here and see if we've got any questions. Timothy, are you hearing anything now? I do have my microphone unmuted. Is anybody else having audio issues? All right, I'm going to go ahead and keep moving with the presentation. PAD SLC devices. These are going to be our detectors and modules that would go on the SLC loop. A couple of high altitude bullet points I want to talk about here real quick. Our LEDs are going to flash approximately once every 4 seconds during normal polling operation, so whenever the panel's polling those SLC devices. Our LEDs are going to go into a rapid flash mode when they're activated, and that's going to be about 4 times every second. So very noticeable difference between polling once every 4 seconds and activated 4 times per second. Maximum number of active LEDs is going to be 30 per loop. Please keep in mind that that only has to do with that LED when that device is activated. Everything else will take place. Horn strobes will still fire, relays will change state. All of the other work that we've done in the software, all of that other zone programming, that will still occur. We will just not get that visible indication of activation once we go past 30. Also, please keep in mind that if any of our relays are picked, whether it's a PAD 100 RM, just the relay, or if it's a relay element of a part of a multi-element module, so the relay of an OROI or the relay of a TRTI, that LED will not go into that rapid flash mode if that relay has been picked. So you would have to use your multimeter to see if that relay has changed state. The PAD 100 and 200 series of detectors, there's the list of all of them here. We're going to talk about the difference between those here in just a second. But the big takeaway here is PAD 100 and 200 series detectors need to go on a PAD 100 series base. None of our detectors come with a base. That base needs to be bought separately. So if you're going to use a PAD 100 or 200 series detector, you will need a PAD 100 series base, and those bases are all listed on the right-hand side of the screen there. The PAD 300 detectors are a new line of detectors that we've built from the ground up, and the PAD 300 detectors need to be installed on PAD 300 series bases. Please understand that a PAD 100 detector, a PAD 100 heat detector, can go on the same SLC loop as a PAD 200 smoke detector, and that can go on the same SLC loop as a PAD 300, say, PCD detector. They all speak the same language, PAD, or powder addressable device. And the big difference there is going to be what base. Those bases are not interchangeable between the 100 and 200 series and ultimately the 300 series. So on the 300 series, there is a magnet test option that is not available on the 100 and 200 series. But please keep in mind that this does not replace the aerosol test that's required as a part of NFPA 72. So you can see there on the screen where you would place that magnet in order to test that detector. I want to talk about the individual sensing elements of these detectors before we start talking about multi-sensor detectors. First detector I'd like to talk about is our smoke detector. All of our smoke detectors have an adjustable sensitivity of 1.1% obscuration per foot. 1.1% is noticeably more sensitive than 3.5. And 3.5 is pretty much industry standard for smoke detectors. So the big takeaway here is we can turn up the sensitivity on our smoke detectors. We cannot turn it down. I do want to take a quick second because smoke detectors is really the difference between the PAD 100 and 200 series. The PAD 100 series of detectors was our original line of detectors. And then there's been a new UL requirement that there is certain burning foods that we need to reject as alarm-causing conditions and certain burning polymers that we need to accept as alarm-causing conditions. So to meet that requirement, we had to rewrite the detection algorithm. When we did that, we had to go back to UL. And when we went back to UL, they do require a new part number for that new detection algorithm. So you won't see any PAD 100 smoke detectors being sold anymore. There may still be some out in the field, but the 200 smoke detectors are what we're going to be currently using in that series. So the smoke detector element is what makes it a 200. So you may still see a PAD 100 heat detector, but if it has a smoke detector element, it's going to be a 2 or a 300. All right, moving on, there's our heat detector. If it's just a heat detector, not part of a multi-sensor detector, we're going to have an adjustable set point between 135 and 185 degrees Fahrenheit. They can be dual purpose, which means that they can be programmed as rate of rise and fixed temperature, or just fixed temperature. So there will always be that fixed temperature element, but we can add rate of rise in as well. Potter's rate of rise is 15 degrees Fahrenheit in 60 seconds. Our heat detectors can be used for low temperature work at the same time as being used for high temperature work. So we can track upwardly mobile temperatures to generate a supervisory or alarm condition, and we can track downwardly mobile temperatures to create a trouble or a supervisory signal. And we can do that at the same time with that same single detector. You'll see we've got a difference in spacing requirements between the 100 and the 300 series. The one thing I will say is the PAD 300 series we've re-engineered, and they are a much better series of detectors across the board. You can see we've got much better spacing on the PAD 300s across that entire range there, 135 to 185. We've got a spacing of 70 foot, where on the pad 100s, when we get above 160 degrees, that spacing starts shrinking. Here's our CO detector. If it's a pad 100 CD, just a CO detector, it has an 8-year lifespan. Every other CO detector or CO detector element, part of a multi-sensor detector, have a 10-year lifespan. Our CO detectors have 3 different set points: 70 parts per million sustained over 2 hours, 150 parts per million sustained over 30 minutes, or 400 parts per million sustained over 10 minutes. So obviously that can be a little problematic when testing. So if you put your control panel into walk test, we will drop those timers, and to activate that CO detector, all you would have to do would be hit 70 parts per million instantly, and then that detector will go active. So walk test drops those timers. Moving on, now we're looking at some multi-element detectors. Here's the PhD. It has a smoke detector element as well as a heat detector element. All of those same bullet points that we discussed about the smoke detector and the heat detector are going to apply here. But we can put this detector in the split mode. As you see there on the bottom right-hand corner of the screen, we can put it in the split mode, and now we have the ability to independently map those detection technologies to have them doing 2 different jobs. I can have my smoke detector firing one relay and my heat detector firing another, if that's something that's required. Or another more practical application might be something like FSAE, fire service access elevators, where we would be required to have both smoke and heat detectors in that elevator lobby. We can accomplish both of those with the pad PhD in split mode. There's a PCD, smoke detector, and a CO detector in a single form factor. It's also worth pointing out that these multi-element detectors only use one SLC address. We'll talk more about what subpoints means here in a little bit, but we do get those independently mappable detection technologies. I get to map a photo detector and a CO detector in split mode. Both of those are going to report to the central station using the same address, but with a different event code. There's a PCHD. That's got all 3 mixed into one. It's got a smoke, a CO, and a heat. So again, we put that in the split mode, and I now have 3 independently mappable detection technologies. Do want to talk about our duct detectors here real quick. The pad 200 and 300 duct is just a smoke detector and a duct detector housing. It has a listed air velocity of 100 to 4,000 foot per minute in that housing, but please keep in mind that there is no integral relay, and you do not have the ability to directly wire a remote test switch to this device. So this is going to be just that smoke detector. You would need a separate relay to perform those shutdown functions. On the other hand, the pad 200 or 300 duct R does have a built-in relay, and that relay's got quite a rating on it. 8 amps at 30 volts DC, or 10 amps at 250 volts DC, and it does also have the ability to have an RTS wired directly to the detector. The pad 100 DRTS is going to be a 4-wire supervised test switch, where the MS series are going to be a 2-wire unsupervised test switch. But in order to fire that relay and to get power for those test switches, we are going to require 24-volt auxiliary power for the duct R. If we don't have that 24-volt auxiliary power, that detector will report a DC power trouble. So we get a very high contact rating on that relay and the ability to directly wire a test switch that we did not have on the duct. On the pad 300s, there's the DD, which is going to be the replacement head for the duct or the duct R, but it is also listed to be mounted directly in a duct or a plenum. When it's not in that duct housing, it's got a listed air velocity of 0 to 3,000 foot per minute. So you can use this for direct damper control or things along that line. It does not need to be in that duct detector housing. Do want to touch on some of our bases here. We've got a couple of different sounder bases. We've got just the regular sounder base, and we have the low frequency sounder base. It'll give us that 520 hertz tone required for sleeping rooms. We also have a relay base. All three of those, the sounder base, low frequency sounder base, and the addressable relay base, we will assign that function to the detector, and then they will consume a subpoint of the address of the detector that's on it. So we're not going to address these bases independently. Say the detector is address number 17 and we put that on a relay base. When we're in the software, we would go to that function, we would park that detector on a relay base, and we would get an independently mappable relay off of that relay base. We also have an isolator base. We have a speaker base, which is not addressable. It's just a speaker and a SLC base. And then we have the 6 and 4 inch unintelligent detector bases that most people use in most situations. One of the big differences between the 100 and the 300 series bases is out of the box, the 100 series detectors lock onto the base, and you have to break off that tab that's shown there in the bottom right hand corner in order to disable that locking feature. On the pad 300s, that is inverted. So out of the box, the locking feature is disabled, and we would need to break that tab in order to enable the locking feature. Here's just a regular 4 and 6 inch base. It's worth pointing out the 4 inch base mounts on a 3.5 inch octagon box, but I will tell you it will not cover that box. So you might use that on drywall or something along those lines, but it's not going to fully cover that octagon box. The 6 inch base will mount on a double gang, octagon, or a 4 square box, and it will cover that box entirely. Both of those bases can accept anything between 22 and 12 gauge wire, though of course SLC needs to be 18 gauge or greater. Next is our sounder bases. A couple of high altitude bullet points here. The pad 100 sounder base offers 75 decibels at 10 foot, where the pad 300 offers 10 more decibels at that 10 foot range, 85 decibels. It is worth pointing out that our sounder bases are part of a two-part output. There's a power circuit that must be designated as sounder base power going to that base. Now, sounder base power does not require an end-of-line resistor. We're not monitoring that circuit for integrity because the sounder bases themselves are monitoring for the presence of that power. Sounder base power in its idle state does have correct polarity 24 volts. And then when activated, that circuit will turn on and off in either a temporal 3 or temporal 4 pattern based on your zone programming. So the only thing that can go on that sounder base power circuit is sounder bases, and sounder bases do require a power circuit that has been designated as sounder base power. Again, that's an addressable base, but we are not going to address that base itself. You can see there under that function column on the right-hand side, we have put that smoke detector onto a sounder base or low frequency sounder base. And then that sounder base power circuit would pulse the temporal 3, temporal 4, and that sounder base would pass that signal along. So if you stick around for tomorrow's programming software webinar, you will see how we program those sounder bases for any number of different situations. There's relay base. Relay base is going to operate much like an addressable relay. It's going to have that same rating, 2 amps at 30 volts or half an amp at 120 VAC. And much like the sounder bases, we would park that detector onto a relay base as opposed to a sounder base like we saw before. And once we do that, we get that mappable relay. Low frequency sounder base, same bullet points we had with the regular sounder base. The notable difference is that they're going to emit a 520 hertz tone as opposed to the 1K tone. Big takeaway here is the pad 100 low frequency sounder base has to be mounted on a 4 square box. It has a pretty deep back to it that goes into the box. I might even recommend a box extension with those. Where the pad 300 low frequency sounder base is going to be surface mount, so we won't need to worry about that. There's our speaker base. This is not an addressable device, but it can be tapped at 25 or 70 volts, and it's got power tappings anywhere from 1/8 of a watt all the way up to 4 watts, and we're going to maintain that high intelligibility across that tapping. But much like the low frequency sounder base, this needs to be mounted on a 4 square box. It's the same form factor as the low frequency sounder base. It has the same protrusion on the back, but instead of having that tone generator, it's going to be just a speaker. There's our isolator base. Of course, we're going to use that for SLC short circuit protection. This is not going to be an addressable device, and it is self-restoring. Amber LED is going to give us an indication if there's a short on the field side of this device. So this does have to be wired in a linear fashion. Here's a list of all of our modules. I'll run through these real quick. We'll talk about some of these a little bit more in depth here. We've got a pull station, the pad 100 PSSA or PSDA. That's going to be a single or dual action pull station. That pull station just has a miniature input module wired on the back of it. So that miniature input module, of course, is meant to be put inside of a box as opposed to mounting on the face of a box. The TRTI has got 2 mappable relays and 2 inputs. Excuse me. Any of our modules that have multiple inputs, we do have the ability to put into Class A mode. We would flip a dip switch on the module itself and make a decision in programming, and we could use that TRTI. We could use those 2 inputs as a Class A input as opposed to 2 Class B. The OROI offers 1 relay and 1 input. This is probably one of our more heavily used modules for things like monitoring conventional duct detectors, where we want to have that dry contact input, but we also want a mappable relay. Another place we see this used quite often is in elevator recall situations where there's a shunt trip. And generally with that shunt trip, we also need to monitor that shunt trip. So an OROI would make much more sense than just using a relay module for that. Dual input modules, just that. It's going to have 2 inputs. It can be 2 Class B inputs or 1 Class A. Again, we're going to talk more about subpoints here in a little bit, but that dual input module is going to be kind of the focus of that conversation. Single input module is exactly the same as the miniature input module, with the exception that it's meant to be mounted on the front of a 4-square box as opposed to being mounted inside of a box. The PAD 100 RM relay module offers an SLC-based relay, has a contact rating of 2 amps at 30 volts, or half an amp at 125 VAC. The PAD 100 ZM or zone module we can use for 2-wire smoke detectors. So that is going to require auxiliary power. We have the PAD 100 and the PAD 300 now isolator module. The PAD 100 IM offers 2 isolated SLC branches, where the PAD 300 is going to offer just 1 protected. So it would be in and out as opposed to 1 in and 2 out. PAD 100 LED is going to be an LED module for situations where we need that remote visible indication, maybe a duct detector, line of smokes above a ceiling or below a floor, any place where we need remote visible indication. The PAD 100 speaker module we'll talk about here in just a minute, but that's going to offer us the ability on voice systems to have sub-circuits. We can take a speaker circuit and cut it into pieces. PAD 100 NAC, notification appliance module. Other manufacturers might call that a control module, but it's going to be wet in, wet out. So if we need single station strobe behavior, we can also use it for solenoid releasing, etc. And finally, last on the list here is going to be the LED key switch input and LED output. There's numerous uses for this, among them being NAC disables. We can make an ad hoc test switch with it. There's several things we can do with that LED. All of our dry contact inputs can be programmed as any of the things here on the list. So we see a lot of the usual suspects here. By default, most of them come in as pull station, but we can change them to water flow, supervisory, tamper. Tamper is a supervisory style signal, but it does have a separate event code from just blanket supervisory. We can remotely trigger a fire drill. We can have a trouble monitor. aux is kind of a catch-all. It was the predecessor to fire alarm. It sends the same event code as fire alarm. Contact input, abort, and release follower. Those are going to be for the releasing guys. We're not really going to discuss those here. Contact input, reset, and silence are input types that we might use on like a remote annunciator. If we've got a graphic enunciator, we would need a reset and silence button. Fire alarm's kind of a catch-all. We do have a couple of different disables. We've got contact input disable inputs, disable outputs, and there's another one that's disable inputs and outputs, and that would all be zone-based disablements. So, if we were going to do a NAC disable, we might have an input as a contact input disable outputs, and then in that zone, we would map what outputs we want to disable with that specific input. Contact input lamp test, kind of goes hand in glove with the reset and silence. Most often that's used for graphical enunciators, but there's other applications like firefighter smoke control panels where we may need a lamp test. CO alarm and CO supervisory we're going to use for the monitoring of conventional CO detectors. HVAC restart is a very specialized input that goes with a specialized relay type that we'll talk about here in a little bit. And then lastly, you can see we've got several alert types, among them being medical, tornado, process, and security. So on the module side, I do want to talk about the PAD 100 speaker module here real quick. We have the ability to have two speaker circuit inputs. We can switch between those, but we can use this to create single station speaker behavior. It is worth pointing out that channel 1 has signaling priority. So what I mean by that is if channel 2 is what activates this device, channel 2 would be playing on the output. If while that were occurring, channel 1 were to go active, this device would drop channel 2 on the output and would start playing channel 1. Because this device is on a speaker circuit, it does consume a little bit of power. On a 70-volt system, it's going to consume about a half a watt. On a 25-volt system, it's going to consume about a 1/16 of a watt. We've got the PAD 100 LED. Again, this is just an addressable LED that gives us that remote visible indication for any number of different circumstances where we may need that. The LED K gives us a key switch input, LED output, and we can use it for disablements, remote fire drill, fan restarts, etc. Excuse me. PAD 100 NAC is going to require a auxiliary power input, but we have that supervised wet output. So, you can use this for a strobe or a horn strobe or releasing solenoid. But please understand if you are doing multiple strobes on this, that no synchronization is provided. So therefore, you would need a sync module on the field side of this device to synchronize those strobes. NACs can be wired Class A or Class B. Of course, Class B would require an inline resistor. Class A would just bring that circuit back to those return terminals. I want to talk about SLC device addressing. So let's start at the panel level here. IPA 60 has a total of 60 SLC devices. AFC 50 is going to be limited to 50. The IPA 100 can do 127 total SLC addresses, where the AFC or ARC 100 are going to be limited to 100. Both of the large format panels are going to be able to do 127 SLC devices out of the box, but they are expandable using the PAD 100 SLCE SLC expansion card you see there in the bottom left-hand corner. Each one of those cards gives you an additional 127 points. So we could put 31 SLCEs on the IPA 4000 to get to 4,064 points, or we could add 9 of them to the AFC 1000 to get to a total of 1,270 SLC points. Addressing on the detectors is done in a binary fashion, so you can see here that each dip switch doubles in value, 1, 2, 4, 8, etc. So if we wanted to have address number 90, we would need to turn on the value for 2, 8, 16, and 64, because when we add all of those numbers together, that comes up to 90. All right, I do want to talk a little bit about subpoints here. This can cause a little bit of confusion. So subpoints are when we have a detector like the PAD PhD in split mode. The smoke and the heat are both going to report using the same address, but we get mappable, separately mappable technologies. The OROI, we get one relay, one input. I think where we have probably the most issue is going to be on that dual input module. Seems like most people use that dual input module for sprinkler monitoring, water flow and tamper. And that's a great example for a way to use our subpoints. So if we're using it for a flow and tamper, please understand if that DIM is set to address number 3, input 1 being the water flow would send address number 3 with an event code of 113. If input 2 were active, it would send address 3 with an event code of 203. So both of those inputs are going to send the same address with different event codes. As long as we have distinct input types, we'll be okay. What we don't want to do is use a multiple input module for, say, 2 strings of pull stations. Central station will never see the difference between the 2 of them because it'll send the same address and the same event code for both of those inputs. All right, I'm going to take a quick break here and see if we've got any questions in the chat. All right, it does not appear that we have any questions, so I'm going to go ahead and keep on moving. Let's talk about our P-Link devices. So P-Link devices are system-level accessory cards that we're going to use to expand the capability of our control panels. That P-Link is a 4-wire connection that's nothing more than RS-485. I do want to talk a little bit about this because this can get people in trouble. That P-Link voltage is 24 volts DC. Please keep in mind that if we're doing just communication with RS-485, that's actually a 3-conductor circuit, A, B, and negative. The A and the B reference that common. The reason why this is important is our panels do not have a dedicated auxiliary power bus. Now, we can take any of those NACs or IOs and set them to be auxiliary or even resettable auxiliary power. But you meter that P-Link negative and positive and see that 24 volts, and you might think that that would be a good auxiliary power bus. First problem is it's not resettable. And the second is this. If we have a device with a bad DC rectifier on it, we can crash that communication circuit. So I'm going to highly recommend, if you're adding P-Link devices to a Potter fire alarm panel, that you only use those P-Link terminals for P-Link devices. Maximum wire length for that circuit is going to be 6,500 foot, but you're more likely going to bump your head on that 1 amp rating long before you bump it on the 6,500 foot. So we're going to go ahead and talk about some of our P-Link devices here real quick. The UD2000, that is going to be our DACT card. Our panels do not have a built-in phone line DACT. We do have an IP dialer, but they don't have a built-in phone line DACT. So if you are doing phone line or phone line adjacent reporting, using a cellular communicator that requires phone lines, you will need to install the UD2000. The CA6075 and the CA6500 are going to be Class A cards for the control panel only. So these will offer Class A return terminals for, the 6075 has got return terminals for the 2 IOs, the 2 NACs, and the P-Link and the SLC. The 6500 is going to have the 6 NACs, and I'm sorry, it does not have IOs. I apologize. The IOs are only going to be Class B. I apologize. The 6500 is going to have return terminals for the 6 NACs, the 2 P-Links, and the SLC. 6075 will have the 2 NACs, 1 P-Link, and 1 SLC return terminals. All right, UD2000 is going to mount behind the annunciator on our control panels. It's going to come with an included jumper cable that would go from the card itself over to the P5 block on the control panel. CA6075 is going to mount over on the right-hand side, the right-hand side of the control panel. It's going to mount over there where you see that yellow square. More specifically, it's going to mount right there on that 18-pin jack. So when you take this out of the box, that card is mounted on that metal chassis. Please remove those 2 screws. Remove the card from the chassis, mount the chassis first, and then mount the card on top of that. Those guide pins that you see there are going to be used to drop that card right onto that 18-pin jack, so you're not going to have any issues. If you try and install it as a full assembly, you do stand the chance of bending those 18 pins on that jack there on the control panel. So those are the two screws that are going to hold it onto the control panel itself. Remove those two screws, and there you go. RA6075 and RA6500 are going to be our remote annunciators. So while we just recently upgraded the side of the screen on the small panels to a 4-line display, the RA6075 stays at a 2x16 display, where the 6500 is going to be a 4x40 display. Both of these annunciators can be used with any of the panels, regardless if it's a small or a large format panel. And they do come in a number of colors, including black, gray, and light gray. You can see the difference in the annunciator size there. The 4x40 on the 6500 up top is obviously going to be much more desirable than that 2x16 on the small annunciator. Our annunciators are not a key enable type annunciator. It's just a locked door. So you open the door, you get access to the buttons, and then that annunciator will come out of that back box. And at that point, then you'll be able to get to those terminals for wiring and addressing. So the wiring's pretty self-explanatory. The P-link, we're just going to maintain polarity, negative, positive, A and B. And then we'll just parallel under those terminals and go out to the next device. Of course, we need to set our address anywhere between 1 and 31. Just to kind of reiterate here, 31 is going to be the highest address we can have on a P-link device. And again, they're going to address in a binary fashion. So the value of those dip switches would be 1, 2, 4, 8, and 16. If you take all of those numbers and add them together, you come up with 31. Other P-link devices we have are the LED16. LED16 is going to give us 16 zones of alarm, trouble, and supervisory LEDs. And then we've got the PSN1000. That is our intelligent power supply. Inside that closure, we have a total of 10 amps of power over 6 Class B NACs, though we can make those Class A. We will lose circuits for Class A circuits, and those circuits work in pairs. 1 and 2 is a pair, 3 and 4 is a pair, and 5 and 6 is a pair. So we can independently make them Class A. I can make NACs 1 and 2 Class B. I could make NAC 3 Class A. I would then lose the ability to map 4 because 4 would be my return for circuit number 3. And then 5 and 6 could also be B. PSN1000 has 2 dry contact inputs built into it. Those can only be Class B inputs, but they do. There are 2 inputs there on the board. And the PSN1000 has an isolated P-link repeater. We'll talk a little bit more about that here in a minute, but that repeater can be very, very helpful. So a total of 31 of these can be installed on a system. Total of 10 amps of power. The PSN1000E is a PSN1000, but the E stands for expanded. It has a larger enclosure than the regular PSN1000. We do have programmable end-of-line resistor values for the NACs and the IOs on the PSN1000, as well as on the control panels. So, and that is independent. So NAC 1 on the control panel could be 2K, NAC 2 could be 10K, PSN1000 circuit number 1 could be 15K, etc. So those are all independently adjustable end-of-line resistor values for NACs and IOs, or NACs and inputs on the PSN1000. All right, not much to say about the cabinet installation. We see the same bullet points that we saw for our control panels there. PSN1000 is going to be 16 3/4 by 16 1/8 by 3.5 inches, and the 1000E is going to be about 10 inches taller. And you can see there's a stacker bracket. That's a P-link card mounted inside of that enclosure. And that would be the purpose of that PSN1000E. We effectively can build out sub-cabinets. Let's talk about the terminals on the PSN1000 from left to right. First, we've got our 2 dry contact inputs, again, Class B only. Moving over, there's our 6 NACs if we're doing Class B. But again, they work in pairs. 1 and 2 is a pair, 3 and 4 is a pair, and 5 and 6 is a pair. So I could make NAC 3 Class A, and NAC 4 would be my return. To the right of that is our isolated P-Link connection, and in the bottom right-hand corner is our main P-Link connection. So please understand we will always use that main P-Link connection. That'll come from the previous device or our control panel, negative, positive, A and B. So what happens if we are maxed out on our distance or on our amperage on that P-Link circuit coming from the control panel? Don't worry, if that happens, we can use the P-Link repeater over to the left-hand side, and at that point, if we use that repeater, please keep in mind, we do not need to assign a device to P-Link 1 or P-Link 2 or to the P-Link repeater. Once it's added in the software, it's on the P-Link circuit, and we are good to go. So we don't need to worry about where that device resides, whether it's P-Link 1, P-Link 2, or on the repeater. Once it's been added into the configuration, we're not going to have any issues. Another card I'm going to talk about is the MC1000. This card will allow multiple control panels, which are designated as clients, to send their signals to the central station through another panel that's been designated as a host. So we can basically make a network of panels using that 4-wire P-Link bus and have a total of 63 panels reporting to a central station through a single panel. 62 of those panels would be client panels. 1 panel would be designated as the host. A couple of things to keep in mind. Unlike a Potter peer-to-peer network, which you have to be an ESD to do, unlike a peer-to-peer network, we do not have the ability to perform any control functions on those control panels. I can't remotely silence panels, etc. And on that host panel, I'm only going to get general zone style information. I'm not going to have point level information at the host panel. Let's take a look at the card there real quick. You can see that we've got 2 sets of terminals. We've got the host P-Link. Obviously, that would be the backbone coming from the panel that we've designated as the host. And then I've got client 1 and client 2 P-Link terminals. So when we look at this in the software, this card might be programmed on a total of 3 different panels. It would be programmed on the host panel. It would be programmed on client 1 panel, as well as on client 2 panel. Again, we're only going to get that general zone style information from the client panels on the host panel, and that's going to be the zone style. So when we look at our software, when we program that zone style, alarm, supervisory, water flow, etc., that is what's going to show on the host panel. It's also worth pointing out that if you need point level reporting, you will have to use the SIA reporting format. Contact ID does not have a qualifier for panel ID in it. So if you want point level reporting using the MC1000, you will need to use the SIA format. Other P-Link devices that we have, Pad 100 SLCE, of course that's going to be a loop card that's going to give us an additional 127 SLC points. We're only going to be able to use this card on the AFC 1000 or IPA 4000 panels. The smaller panels we cannot add additional loop cards to because we are locked to the number of supportable SLC devices. DRV50 is going to give us 50 user configured LED outputs as well as 6 system level outputs. RLY5 is going to give us 5 user configured relays. The RLY5 is really an expansion card for some of our conventional panels, but it uses P-Link, so we did make it available to you here. Does have a little bit higher of a contact rating, 3 amps at 24 volts DC or 3 amps at 125 VAC. So if you need a little more gas in the tank for your relays, you might want to use the RLY5. All right, we also have the IDC6. The IDC6 card gives us 6 IDC input circuits that we can use for 2-wire smoke detector circuits. This does have a UL limitation that it needs to be in the same room as the control panel within 20 wire foot in a protected pathway. So if that's not going to work for you, please remember we have the Pad 100 ZM zone module that gives us 2 Class B 2-wire smoke detector circuits. All right, other cards we have, SPG 1000 is going to be a printer card, serial and parallel printer output. FCB 1000 is a card that's going to give us an additional Ethernet port that we're only going to use for central station reporting. So instead of using the PCOM port on the control panel, we can use the FCB 1000. And the concept there would be maybe our panel is remotely located from our modem and router, and we don't want to go through all that customer switching equipment, because if we do, all of that equipment requires standby power. So we could use the FCB 1000. We get an additional Ethernet port for IP reporting only, and we can put that much closer to that modem and router and have much less equipment to provide that standby power with. The FIB 1000 is a card that allows us to convert that 4-wire P-Link to and from fiber optic. So if we're going from building to building and we don't want to run it on copper, we can use the FIB 1000. All of those cards are available in a 19-inch rack mount, the FIB 1000, FCB 1000, and the SPG 1000 cards. So the vast majority of those P-Link cards come on a stacker bracket like you saw there, and that's so that you can easily mount them inside of the enclosures. Depending on the location, we can mount those brackets up to 3 high. So large format control panels have the ability to take 6 of those cards. You can see there on the left-hand side, that's an AFC 1000. So it'd be 2 wide and 3 high. And the PSN 1000 also has that same capability, 3 high and 2 wide. So you could build out a sub-panel in that PSN 1000. We do have a couple of accessory enclosures. The AE2 will hold a total of 2 cards. The AE8, of course, will hold 8. And the AE14 shown on the left there will hold a total of 14 accessory cards. P-Link capacity. Small panels can host a total of 64 P-Link devices. In most cases, 31 of any one distinct type, though there are a couple of exceptions. Large panels can host a total of 128 P-Link devices. So the exceptions to that 31 rule are going to be the FIB 1000. That's the card that converts P-Link to and from fiber. Of course, that's going to be installed in pairs, so we'd be limited to 30. The LED 16 and the DRV 50 are going to be limited to 10 on the smaller panels, and that has to do with power consumption. Again, the LED 16 is a 16-zone annunciator of alarm, trouble, and supervisory LEDs. The DRV 50 offers 50 user configurable LEDs. FCB 1000 and the UD 2000 are central station reporting cards, so of course we would only have 1 per system. P-Link addressing, again, it's going to be binary, so 1, 2, 4, 8, and 16. And you can see there, we can have up to 31 annunciators, 31 loop cards, etc. It is worth pointing out that if we're allowed to have a total of 64 P-Link devices on the small panels or 128 on the big panels, that means we can have duplicate addresses. But those duplicate addresses need to be on distinct device types. And what I mean by that is I can have a remote annunciator at address 1, I can have a PSN 1000 at address 1, I can have an SLCE loop card at address 1, and the system will know the difference between those. What I cannot have is 3 annunciators all at address 1. We will have issues with that. Again, going to take a quick second here and see if we've got any questions in the chat. Michael asked, are the PSNs synced off of the P-Link? That is a phenomenal question, Michael, and the answer to that is yes. We're going to talk a little bit about synchronization here in a second, so I don't want to give too much away. But the short answer to that is synchronization is provided off of the P-Link circuit. Yes, sir. All right, output circuit configuration. So the small panels have a potential of 4 outputs, 2 NACs, 2 IOs. If both of those IOs are being used as outputs, please keep in mind that that only has a 5 amp power supply, where the large panels have a 10 amp power supply and may have a total of 10 outputs over 6 NACs and 4 IOs. PSN 1000 may have a maximum of 6 outputs if everything's Class B. And please keep in mind the PSN 1000, That's our intelligent power supply. There's nothing conventional about it. It's only going to trigger off of the P-link. So it has to be paired with a control panel. So here's all the different things that we can program those outputs at, whether they're NACs or IOs, or the NACs on the PSN 1000. NAC general purpose is going to be a polarity correcting 24 volts with no synchronization. So we might use that for something like a bell, but it is going to be polarity correcting. It is a supervised circuit. Aux constant and resettable do not require an end-of-line resistor. So aux constant is going to be putting out 24 volts no matter what. Resettable, of course, will drop power when the panel's in a reset cycle. Door holder and door holder low AC drop. We can use these circuits for door holder circuits, which means they're going to have correct polarity when in the idle state. And when the zone that they are in goes active, we're going to drop power to those circuits. So again, we're not going to require an end-of-line resistor for those. Aux ANSI is kind of a goofy circuit type. It was the predecessor to sounder-based power. Aux ANSI is just pulsing out a temporal 3 24 hours a day. That's all it does, just puts out a temporal 3. So if you don't need T3, T4 signaling, you could use aux ANSI, and then that sounder base would just complete that circuit and pass that pattern along. City tie is kind of an old technology. There's not a lot of places using it anymore. Parts of Boston, a lot of naval facilities on the West Coast for some reason will still use city tie. But that's if we ever have to tie into a McCullough loop in a city tie box. Sounder-based power. I'm going to emphasize this again. Sounder-based power does not require an end-of-line resistor. In its idle state, it does have correct polarity 24 volts. So we're not worried about the integrity of that circuit because the sounder bases that are on that circuit are monitoring for the presence of power. So if that circuit goes out and I have 10 sounder bases on that circuit, I will have 10 DC power troubles, one from each of the sounder bases being powered off of that circuit. When that circuit goes active, based on our zone programming, the circuit itself will pulse on and off in a T3 or T4 pattern. That pattern is not dictated at the sounder base. It is dictated at the level of the circuit. So this is not auxiliary power. You cannot put anything on this circuit but sounder bases. And sounder bases need a sounder base power circuit in order to operate correctly. Release solenoid behaves exactly the same way as NAC general purpose, with one very notable exception. If the release solenoid is unable to see its end-of-line resistor, it will generate a supervisory signal as opposed to the trouble signal that would be generated by the general purpose. And that has to do with that release solenoid. If that's basically saying a protection circuit has been disabled. It's tantamount to a control valve on a sprinkler system being closed. So we're going to generate a supervisory signal as opposed to a trouble. And then finally, we've got synchronized horn strobe circuits, which leads to this slide. Potter has a technology that we call quadrisync, which offers us the ability to synchronize different manufacturers' strobes off of the same control panel and power supplies. We can support system sensor, Wheelock, Gentex, and AMSECO strobes. And as you can see here, system sensor would be on IO1, Gentex would be on IO2, AMSECO would be on NAC1, Wheelock would be on NAC2. And if all of those circuits were activated at the same time, they would all synchronize their strobes together. Big takeaway here is system sensor appliances need to be on that system sensor circuit, AMSECO on that circuit, etc. So we just need to make sure we're putting the right appliances on the right circuit, but we will achieve system-wide synchronization with that quadrisync. That synchronization does pass to PSN 1000 power supplies over the P-link. So wiring is pretty self-explanatory. If I'm wiring notification appliances class B, of course, I'm going to have an end-of-line resistor. If I'm doing them class A, coming off the control panel number 1, I would have to have a class A card. But I would not use an end-of-line resistor. I would just return that circuit to that CA6075 or CA6500 card. All right, so I do want to talk about the individual programmability of each of our circuits. So here you can see NAC 1 would be AMSECO. I could make NAC 2 Gentex. NAC 3 could be door holder. 4 could be constant power. 5 could be sounder-based power. And 6 could be a system sensor sync. So we're going to touch each one of those circuits and apply a function to them, whether it's a synchronization or some other output function. We can also make those circuits unused. Same holds true for the IOs. We can apply different output patterns or different output functions to each one of those circuits independently. Again, IOs have a 1 amp rating when used as an output, where NAC amp rating. PSN 1000, we have that same ability. We can independently map and function each one of those circuits. I do want to talk about our relay types here real quick. So our relays, whether it's a PAD 100 RN, if it's the relay off the RLY5, or the relays off something like a TRTI, we can assign different functions to each of those relays, and we can map those relays independently. There are more functions than what we're showing on the screen, but these are probably the most common. Addressable relay general purpose is going to be what we're going to use for most control functions, but please keep in mind that that relay is a silenceable relay type. So if I have it in a zone that is set up as silenceable, and I hit the silence button on my control panel, that relay will return to its normal state. HVAC shutdown, that's not an overly specialized relay type, but I do want to talk through 2 scenarios here with that relay. So New York City has a very interesting piece of code that says if a fire alarm control panel shuts down air handler units, resetting the control panel shall not return those units to service. So what New York City wants is the ability to reset the panel, to see that that situation has returned to normal, so that situation is cleared, and then we would need a distinct input in order to return those units to service. So there is an input type called HVAC restart. So if I have a zone with an HVAC shutdown relay and an HVAC restart input in the same zone, that relay will not return to normal when the panel is reset. You'll have to reset the panel, the condition will have to clear, and then we can trigger that input. Most likely it's going to be an LEDK because we want a privileged input for that HVAC restart. So then we would turn the key and that relay would go to normal. However, that doesn't mean that that's the only way to use that relay. We can use that HVAC shutdown relay in normal air handler shutdown work. If I don't have that restart input paired with that relay, the relay will return to normal when you reset the panel. The other nice thing about that relay is it is intrinsically a non-silenceable relay type. So I can put that in a silenceable zone where then I could hit the silence button and quiet the annunciator, but keep that relay in its off normal state until I reset the panel. Next one we have is zone trouble. This is probably not one you're going to use too terribly often, but let's say I have a zone with 100 smoke detectors and one relay programmed as a zone trouble. If any of those smoke detectors were to go into alarm, that relay will not change state. However, if one of those smoke detectors has a dirty detector trouble, or it goes missing, or any of the other troubles that we may see, there would then be a trouble in that zone. If there's a trouble in the zone, then that relay will change state. Last relay type is reset follower. This is a very useful relay type if you understand what it does. So what it does is the only time it changes state is when the panel's in a reset cycle. It is an SLC device, so it has to go into a zone. It doesn't matter what zone or what zone style, because the only thing that's going to affect its state is if the panel's in a reset cycle, and then that relay will change state. Where we see this most often used is in air handler units where a duct detector has been installed and we're not powering that duct detector, but we do want to be able to cycle power to that detector because we're monitoring it. So in that case, I'd set that relay up as a reset follower. I would take one leg of that power, normally closed and common, so that it normally has power. I reset the control panel, closed would go open, we drop power to that device, and then it closes back up and we cycle power to it. All right, input circuit configuration. We've already looked at this list, but I'll show it to you again. All of our inputs, whether they're on a SIM, DIM, or MEM, the IOs on a control panel, the inputs on a PSN 1000, we can apply any of these input types to any of those inputs. Big thing to keep in mind on our inputs is that we cannot exceed 100 ohms or 10,000 wire feet. All right, again, I'll see if we've got any questions. No questions, so I will go ahead and continue on. One of the cool things that Potter just very recently released is the ability to do programmable soft keys. So the functions that we can do on those soft keys are going to be contact input, activate outputs, disable inputs and outputs, disable outputs, HVAC restart, or lamp test. So we have the ability to program those soft keys in a couple of places. Our integrated voice panels have banks of buttons that we can assign those soft key functions to. The PSK 1000 shown there on the bottom is going to be a bank of 16 soft keys that we can apply any of those functions to. And then finally, the SCUI, our smoke control user interface, that has to go on a IPA panel, but there are 2 additional soft key buttons on the bottom. PSK 1000 only has those programmable soft key functions that we mentioned. The SCUI 1000 has those soft key on those bottom buttons, like I just said. And on our voice panels, we have those soft key as well as the integrated voice functions. And we can also have that same soft key functionality on the LOC 1000 and the RM 1000. We do have a couple of new control panels, the AFC 1000E, IPA 4000E. Same control panels you're used to, they just come in a different enclosure. You can see there it's got a smoked plexiglass front. And in the dead front there, the swinging dead front, we have the ability to mount the PSK 1000B or the SCUI 1000B. And that's going to be a board-only version of that soft key or smoke control card. All right, we're going to program our panels through the PCOM network connection. That's going to be that Ethernet port on the top. It's worth mentioning here that you cannot program a Potter control panel through the keypad. You can run a learn function, but we're going to be very limited with what can happen there. Virtually all of our dry contact inputs are going to be pull stations. All of our outputs are going to be general purpose. So we're not going to have a program that's really going to have any sort of longevity using that learn. So you're going to need a Windows PC running Windows 10 or greater with an Ethernet port and a Cat5 cable. So we're going to generally do a direct connection. We're going to plug that Cat5 cable into our computer and then plug it directly into the control panel. Now, I do realize most PCs do not have Ethernet ports built into them. So just about any USB to Ethernet dongle is going to work just fine here. So when we plug in, it's worth pointing out that by default, our control panels are set up for DHCP. DHCP stands for Dynamic Host Command Protocol. What that means is the control panel does not have an IP address programmed into it, and it's reliant on something else on the network to give it an IP address. So when we make that connection, the control panel is going to recognize that there's a connection, as is your computer, and your computer also needs to be set up for DHCP. So the control panel is going to ask your computer if it can give it an IP address. Of course, the answer is going to be no. So then after 30, 45 seconds on the annunciator, we're going to see it say link local IP. Then it's going to flash an IP address of 169.254.150.70. Don't worry about memorizing that IP address. That's going to be universal to virtually every Potter panel. And if you don't remember what IP address the panel pulled, if you're at the top menu on the annunciator and you press the right arrow, it will show you the IP address. So once that connection is established, we can send and retrieve configurations from that control panel without jumping through any additional hoops. And that is because we're in that link local mode. Now, we can also put the control panel on a local area network. This is going to be a little bit different than that direct connection. So once we plug into that local area network, our panel is going to get a response from what's known as a DHCP server. There's going to be something on the network that can give it an IP address. So much more rapidly, the panel is going to go from obtaining IP to IP configured to it's going to advertise the IP address that was assigned to it by the network. So here's where we get a little bit of a stumbling block. We can always retrieve a copy of the program. We cannot necessarily always send a copy of the program. If we have a direct connection, we can send a copy of that configuration, no problem. If we're on a local area network, I need to enable remote access on the annunciator before I'm able to send that configuration to the panel. Because once we're on a local area network, you can't prove where you're at in the world. And so therefore, we have a NFPA code compliance issue, which says if we send a configuration to the panel, we need to test those programming changes. So in order to meet that, we need fingers on buttons on that local annunciator to enable that remote access mode. When we're in that link local mode, it's obvious that you're there because we've had that DHCP failure. All right. Again, once we're on that local area network, we can do IP central station communication. And I think there's a couple of very good benefits to doing IP central station communication. I realize that most people are using cellular, but there are a couple of things with IP communication that I would like to talk about. Much like cellular, NFPA says that this is listed for sole path, so you do not need a separate communications path. I think probably one of the most important benefits is checksum. So what that means is when the panel sends a signal, at the end of it, it might say, I sent 165 bits. If the receiver agrees, we know that the right signal was sent through. If the receiver disagrees, then the panel will resend that entire data packet until everybody agrees that the correct amount of data was sent, ensuring that the correct message was received. A more real-world version of this checksum would be if you've ever watched HDTV over the air, and you might see screen pixelate or the screen entirely go black or even portions of the screen going black. Those are checksums that are failing, and then the TV's just dropping that data. It doesn't know what to show. The speed of the internet allows the signals to be delivered almost instantly. That very much holds true. If you're doing analog or DACT signaling, you can quite literally hear each one of those signals going through. Contact ID generally is about 3 seconds per signal, where if we're on the internet, it's going to be incredibly faster. That bottom bullet point says loss of communication between the control panel and the supervising station is known within 90 seconds of using the default program time. I do want to talk about this a little bit. So every 20 seconds, the panel sends a message to the central station receiver. It says, I'm here. And the receiver says, I hear you. So we have a very simple call and response that's taking place. That 90 seconds is how long do we let that process fail before we generate a communications trouble at the control panel and at the central station. I'll tell you right now, 90 seconds is not nearly long enough, but we have purposely put it low. You need to talk with your central station about what their supervision interval is. Code allows us to push this out to 1 hour or 3,600 seconds, though some central stations may have it at 1,800 seconds or 30 minutes. We put it at 90 seconds because we would rather generate unnecessary communication troubles and compel you to have that conversation with your central station than to assume what that supervision interval is going to be. So if you're going to do IP reporting, please check with your central station what that supervision interval is going to be. We want it to be the same on both ends. So we generate that communication trouble simultaneously at the control panel and at the central station. A couple of things to consider. Now we're taking that signaling and we're going through customer switching equipment. Therefore, we need to give it 24 hours and 5 minutes of standby power. If it's a regular fire alarm, if it's a voice system, we would need to give it 24 hours and I believe 15 minutes. Our panels are compatible with SureGuard IP receivers, which is pretty much the gold standard anymore. All right. One of the other cool features we have on our panels is once we have that internet connection, we can send and receive emails from our control panels. This is not a subscription. You don't need to pay for it. You just have to have internet to the control panel. All of our panels have an email address, and it's going to be that netbios at potterlink.com. So in this example, it would be IPA 60, 1, 2, 3, 4, 5 zeros, 12. So IPA 60000012 at potterlink.com. And that net BIOS can be found on the heat sink of all of our control panels. In this case, bottom left-hand corner. That heat sink's over on the left-hand side. So we've got a couple of different menus in the software. The first one I want to talk about is email reporting. So we can have the panel send status emails, alarm trouble supervisory, when the condition occurs. So in this case, that would be customer@building.com if there's an alarm trouble or supervisory. You don't need to send all three. I've used this before with customers where we did a school district and the facility manager only wanted trouble signals. So we put in facilities@schooldistrict.com and just check the troubles box. And anytime there was a trouble on any of their control panels, they got an email. We also have the ability to schedule history and detector status reports. So we can schedule that up there on the top, email reports on these days, and you can select certain days of the month. I'm going to highly recommend if you're going to do this that you do it in the first half of the month, because if you set that for the 31st, there are several months that you will not get that history or detector status report. If you have questions about the detector status report, we do have a video on the website, and I will discuss it in tomorrow's software webinar. Lastly, we have the ability to enable email requests. So we can request emails from the panel, and we're going to talk about that here in just a second. So on the status emails, alarm trouble supervisory, again, when the condition occurs, and it goes without saying that this is not intended to alert authorities. Here's a look at what a system status email might look like. You'll notice there that we've got some specific job site information. There is a form in the software where we can enter that information because, frankly, AFC 1000-1783, I apologize, that means nothing to me. I have no idea what panel is sending me that email. So I can put some site-specific information in there. You'll notice above that it even tells us what version of firmware the panel's running. In this case, it's an AFC 1000 running firmware version 8.01. So that's a pretty old firmware. Below, you can see the two events that took place. Looks like a pull station was pulled, and then about 5 seconds later, it was silenced. So that is a case of multiple signals being sent in a single email. So the history and detector status reports, again, we can schedule those daily, weekly, or monthly, and that's going to be attached to the email as a text and Excel file. So you're going to have two attachments, one text and one Excel. Another option that we have is service reminders. So in this case, we can schedule an email to go out to up to 20 different people. We can write our own message in the body of that email. We can also attach a history and detector status report. The nice thing about those service reminders is, we can use that as a test and inspect reminder. I like having the history and detector status attached because I can look at that history report, and if I've got all 4,000 events in, the last 6 months, I might send more than one technician out. I've got an incredibly busy panel. What's going on with this panel? Or if I've only got 10 events in the last year, I know I've got a fairly stable panel. I also like to have that detector status report attached because it gives me some good actionable intelligence as to the health of the detectors on my system. Again, for more information on that, you can either watch that video or you can join us tomorrow on the software side, and we'll talk about that detector status report. So on that email requests, that requested email has to come from the programmed email address in the panel. So I'm going to recommend not using a named account. Don't use jamesb@pottersignal.com. You might want to use service@pottersignal.com. And in the subject line of that email, you can put configuration, status, and or history, and you will get that back from the control panel within, I'd say, about 10 minutes. Panel checks for emails every 5 minutes, so don't expect a response back immediately. You can make multiple requests in the single email, but you're going to get multiple emails back. So if you put in status space history into your email going to the panel, you will get one email back with a detector sensitivity report and a separate email back with the history report. I really like this for after-hours service, where a customer says that their panel's going off, and instead of necessarily rolling a truck, we have the ability to easily retrieve that panel's history file and see what's going on with that system. All right, we're near the end of our presentation here. I'm going to take a look and see if we've got any questions. And again, no questions.
For more information about Potter products, please visit our website at pottersignal.com. To access additional training resources, check out our online training portal at academy.pottersignal.com. Stay connected with us on social media for the latest updates and news.